Hello students. So this is a question from graph theory. It is a 2 marks question. And the question is the number of distinct minimum spanning trees for the weighted graph below is dash. Okay. So what is asked is we have to find the number of minimum spanning trees for a simple connected weighted graph. Okay. So this is the given graph and we have to find the minimum spanning tree, the number of minimum spanning trees. Okay. Because there are multiple edges with same weights, there is a possibility that there may be more than one minimum spanning trees. Okay. So let's try to find the number of minimum spanning trees. So let's say this is the part 1 of my graph and let's say this is the part 2 of my graph. Okay. So we have to select the edges with the minimum weights. Now, because there is only one edge between which is joining part 1 and part 2, this edge will always be there in my minimum spanning tree. Okay. So here, let's write first the number of vertices. So let's say the number of vertices is 7, and to create the minimum spanning tree, the number of edges in the minimum spanning tree will be 6. Okay. So this edge is already there. This edge is already there in my minimum spanning tree. I have to include this edge in my minimum spanning tree. Now from this part, to connect these 3 vertices, let's give this a name A, B and C. Okay. To connect these 3 vertices, I need one of the 2 edges from these 3 edges. Okay. What I need is any 2 edges. So because the weights are same, I can select this edges in 3 ways. Because there are 3 edges, I can select any 2 edges in 3 ways. Okay. So either I'll select this AB and AC or BC and SE and so on. Okay. Now from this part, there are 2 edges which has minimum weight 1. So these 2 edges will always be there in my minimum spanning tree. Now let's say this vertex is D, this vertex is E, this vertex is F. So I have to select one of these 2 edges because I want a connection between this part, this graph to E. I want to connect to vertex E. So I want one of these 2 edges. Okay. Either I'll include ED or I'll include EF. So which can be done in 2 ways. Okay. So the number of minimum spanning trees which are possible is nothing but 2 into 3. Okay. This can be done in 2 ways, and this here the edges can be chosen in 3 ways. So the number of minimum spanning trees is 6. Okay. So the answer to this question is 6. Thank you.